Good morning, student. Now today we have to see next topic, that is uniform circular motion. Okay, up to now we carry out study of motion. So we have to today see circular motion. First of all, it is a motion, but which type of circular motion? We are already studying uniform motion. Now we have to study uniform circular motion. So first of all, circular motion, that word indicates that this motion is simply in the shape of circle. Motion of an object is in the shape of circle. So circular motion is not simply motion of an object around the circumference of circle. Okay, so such a way that suppose this is a one object, okay, having mass m. So circular motion means what? This is a one circle. Then if an object move along circumference of a circle, on the circumference of a circle, then that motion of an object is simply called as a circular motion. Now we have to see uniform circular motion. We have already studied uniform motion. Uniform means what? Simply in equal time interval if an object cover equal distances. Okay, means suppose we are consider many examples of every 5 seconds we draw graph, velocity time graph. Okay, so there are we study if an object cover equal distances in equal interval of time, then that motions are called as a uniform motion. Here uniform circular motion, again simply uniform motion along the circumference of circle. Example is tip of a clock. Okay, suppose consider tip of a clock that cover equal distance in equal interval of time. Okay, so that motion is nothing but the uniform circular motion. So in uniform circular motion, suppose we have to consider this is a starting point of an object. Okay, if it cover one circular path and again come on its original position, so at this position after covering that much distance, okay, means it cover distance equal to circumference of circle. Okay, this is the starting point and this is the end point, then this object cover distance will be equal to the circumference of the circle. So here speed is given by distance upon time, but here distance is how much? Circumference of a circle, and time. So here one complete round here, okay, one complete round and here. So we already studied periodic time is what? Time taken by an object to cover one rotation. Okay, one full motion around the circumference of circle. Okay, so this t is the time period to take complete one rotation around the circumference of circle. So its velocity should be equal to 2 pi r divided by t, where r is the radius of this circle. Okay, so simply circular motion means what? Motion of an object and on the circumference of a circle, that is simply called as a circular motion. And in circular motion, speed is given by circumference upon time, so its velocity should be equal to 2 pi r divided by t. So here what happened? Each and every point, okay, velocity will get changed. Okay, due to how? Due to each and every point, what happened? Direction of motion get changes. Okay, direction of motion get changes on each and every point of this circumference. Okay, so that is why it is also called as a accelerated motion. It is which type of motion? Accelerated motion, because of its velocity goes on changing on each and every point due to the change in direction on each and every point of this circle. Okay, and so this is the formula of a speed that will be circumference of a time, and we know circumference is equal to 2 pi r divided by t is periodic time, where r is the radius of circle. Then next topic is which is the direction of a motion of an object in circular motion. So always remember that direction of motion of an object in circular motion is always tangential direction to the circle. Which tangential direction? So suppose if an object is here, then direction of motion is tangential to this circle. If object is here, then its direction of motion will be here. Okay, so such a way that you have to remember in circular motion, on each and every point direction of motion is always tangential to the circle. Okay, so next topic we have to see, that is Newton's law of motion. Okay, directly go towards the point. First we have to see some examples. Okay, first of all, if suppose one big stone is here, okay, suppose its mass is 100 kg, so it will remain on that particular position up to when we don't try to move it. Okay, means ultimately by itself it will not be moved from its position. Okay, then another one example is, that is if we switch off the rotating fan. Okay, at that time what happen, as we switch off the button, then directly at that particular instant fan will not stop. Okay, it remain to try in motion for some time. Okay, after passing some time it will stop. Okay, if branches of a tree are shaken, at that time fruits are fall on the downward side or on the earth. Okay, so due to that, what we understood, okay, we understood that we are already studied in 8th standard. Okay, what? Inertia of an object. So Newton's first law of motion is related to the, or it described inertia of an object. Okay, we are already studied about inertia. Inertia is simply what? It is a tendency of an object to resist change in a steady state or change in a motion. Okay, if any object is stationary or steady, then it tries to remain in a steady state always. Okay, or suppose if an object is in motion, okay, at that time it will always tries to remain in motion. But as we apply somewhat force on that object, at that time what happen? Okay, its state will get changed. Okay, and at the time of changing its state, it tries to remain in its particular original state. Okay, some example I already told you, that is the example of fan. Okay, as we switch off the button, then fan has to stop at that particular instant, but still fan does not stop. It tries to remain in motion. Okay, then slowly it's slow down, and then after some time it will be stopped. But as we switch off the button, at that time it not stop. Okay, another one example of inertia is, if we are, suppose we are traveling in bus. Okay, at that time what happen? If driver applies brake, at that time we are sit in bus and our body is in motion. As the driver applies brake, at that time our body does not want to stop. Okay, it tries to maintain that motion. So bus stop, but our body does not want to stop, due to why we move in forward side. And at a time when bus is start, then also we move on backward side, because initially when bus is start, we are stationary, okay? Bus gains some speed, but our body want to stay stationary. Due to that, we are pushed back when bus is stuck, okay? So these are the tendency of any massive body, okay? What it always tries to resist to change in its state, whether it is a steady or it is in motion. On whatever the state, it always tries to resist change in that state, okay? So that property to resist change of a state is simply called as a inertia, and Newton's first law describes about inertia of an object, so that is why it also called as a law of inertia, okay? So that is about the inertia. Now we have to see balance and unbalanced forces, okay? So suppose this is a one object of 100 kilogram, okay, and two persons are pushing that object on opposite side. If this person apply 115 Newton force in this direction, okay, and this person also apply 115 Newton force and this opposite side, okay? So these both forces are in opposite side. So on which direction will that block move, okay? So here what happened, amount of force is same, so that ball will that box will not move from its position. But now suppose if this is apply 115 Newton force and this will apply 110 Newton force, at that time what happened, both the forces applied on this block are not equal, so 5 Newton force will act more on this side, so the resultant force will be in the direction of higher force, okay? So net force act on this box will be 5 Newton and it will be in the direction of this 115 Newton force, okay? So then this box will be able to move from its position, okay? So simply from that we are studying balance forces means what? Balance means simply we can say equal, okay? Balance means what? Equal. If we apply equal force on an object, then motion will not be possible, okay? So if we want to move an object, then we have to apply somewhat unbalanced force on it. Now consider another one example. Suppose if an object in motion, okay, then we have to stop that moving object, then also we have to apply somewhat unbalanced force. If we apply balanced force, then we cannot able to stop that object, okay? So Newton's first law tells us about somewhat this balance and unbalanced forces, okay? Suppose we see here one example, okay? If we want to move block, then what happen? We have to apply some unbalanced force, then and then we can able to move that object, okay? So Newton's first law tells us that the statement of Newton's first law is every inanimate object continuous in its state of rest or state of motion unless it is acted upon by some external unbalanced force, okay? What happened? Every inanimate object, every object continuous in its state of rest, whether it is in rest condition or whether it is moving. If you want to move steady object or if you want to stop moving object, then you have to apply some external force. But which force? Unbalance, okay? If you apply balanced force on that object, at that time that object will not be stopped. we have to apply somewhat external unbalanced forces, then we can change the state of that object, or we can stop of that moving object. Okay, so here we have to understood what is the balance and unbalanced forces and what is inertia. These are the two important part of the Newton's first law of motion. Okay, statement of Newton's first law is important. Inertia is important. Inertia is simply what? Every massive body tries to stay in rest position or in moving position. Okay, or it resists to change in that particular state. Suppose we are running. Okay, we are consider example of running. Okay, so this is 100-meter running track. We are start from here, and this is suppose 100-meter mark. If you see this event in Olympicals, okay, so there are we see if these runners are start from here, then they are not stop exact here. Okay, actually they want to stop here, but their body does not stop on this point. Okay, they will be cover somewhat more 20-30 meter distance, then get slow down their speed, and then they will stop. But actually their distance is finish here, but still they have to go somewhat more distance, they have to cover somewhat more distance, then and then they will stop their running. Okay, so simply what happened, their body does not want to stop on this point. Body tries to continue in moving state. Okay, so that is why they will go somewhat distance ahead from this mark, and then they will stop. Okay, so inertia is the very basic property of any massive body. Okay, and then balance and unbalanced forces. Balance means what? Simply equal, and unbalanced means what? Somewhat more or somewhat more. Okay, if any object according to Newton's third law, equal and opposite force apply every object and other object. So we have to apply somewhat more force on that particular object. Then and then we can change its state, whether it is in stationary or it is in motion. Okay, and the statement of Newton's first law, every object continues in its state of rest or state of motion until, okay, up to how much time? Up to that much time when we will not apply somewhat external unbalanced force. Okay, suppose one heavy stone is here, then it will be remain up to thousands of years. Okay, if you not try to move it. Okay, but if we apply force and try to move it, means we have to apply some external unbalanced force on it. Then what happen? It can be, we can change its state. Okay, so simply Newton's first law of motion is also called as a law of inertia, and that tells us about the property of most massive bodies, that is the inertia, that object tries to remain in its particular state, whether it is stationary or it is moving, until we does not apply somewhat external unbalanced force. That statement you have to remember. Okay. Okay, next topic we have to see Newton's second law of motion. Okay, directly go towards second law. Statement of second law. First we have to see what is momentum, because second law is also called as a law of momentum. Okay, so first off, what is momentum? Momentum is nothing but the product of mass and velocity. Product of mass and velocity of an object is simply called as a momentum. Okay, so momentum is denoted by letter P. P is equal to m into v. Product of mass into velocity is simply called as a momentum. Momentum is a vector quantity. Okay, means vector means simply what? To describe this quantity we need magnitude as well as direction. So it has SI unit, kilogram meter per second. Okay, is the SI unit of the momentum, because mass kilogram and velocity meter per second, kilogram meter per second. Okay, product of mass and velocity is simply called as a momentum. Now if one object is striking on the another object, okay, then the whatever the change takes place after the collision of these two objects is depend on the velocity and mass of the other object. Okay, and this product of mass and velocity is simply called as a momentum. Okay, now we have to see statement of Newton's second law, okay, or law of momentum. So this statement of Newton's second law is the rate of change of momentum. What? Rate of change of momentum is directly proportional to applied force. Rate of change of momentum is directly proportional to applied force, and change in momentum takes place in the direction of applied force. Okay, this is the statement of Newton's second law. What? The rate of change of momentum is directly proportional to applied force, and change in momentum takes place in the direction of applied force. Okay, that is statement you have to remember or write in your notebook. Okay, all three statements of three laws you have to well remember. So now suppose if m is the mass of an object, okay, it moves with initial velocity u and its final velocity will be v. Okay, the mass object of mass m which having initial velocity u and its final velocity v. Okay, so its initial momentum is simply what? Product of mass and velocity. Mass is m and initial velocity is u, so its initial momentum will be mass into initial velocity, that is the mu. Then its final momentum will be mass into final velocity v, m into v. Okay, so rate of change of momentum is simply what? How much momentum change with respect to time. Okay, so rate of change of momentum will be final momentum minus initial momentum divided by time. Okay, so we have here final momentum is how much? M into v. So mv is the final momentum. Initial momentum is mu divided by time t. Okay, so here m is common, so v minus u divided by t. Okay, but we know this v minus u divided by t. V is what? Final velocity. U is what? Initial velocity divided by t. Change in velocity with respect to time, that is simply called as a acceleration. Okay, so simply instead of v minus u divided by t, we have to put a here. Okay, so it will be ma. Okay, so this ma, okay, this is what? Rate of change of momentum. Left hand side is what? Rate of change of momentum, that directly proportional to what? Applied force F. Okay, ma is directly proportional to applied force. So here we have to remove this proportionality constant. Okay, proportionality sign. Okay, so that is why we have to introduce here one proportionality constant k. So this equation will become F is equal to k into ma. Okay, where k is the proportionality constant which having value 1. Okay, so this F is equal to ma. Okay, that is the formulation of Newton's second law. Okay, here you have to remember what is momentum. Momentum is product of mass and velocity. Then you have to remember statement of second law. Statement is what? The rate of change of momentum of an object is directly proportional to applied force, and changing momentum will take place in the direction of applied force. That is the statement of Newton's second law, and you have to remember this formulation. Okay, momentum is product of mass and velocity. If m is a mass, initial velocity u, final velocity v, then initial momentum mu, final momentum mv. Rate of change of momentum will be final momentum minus initial momentum divided by time. So we get finally F is equal to ma. That is the Newton's second law of motion. It also called as a law of momentum. Okay.